we can use an absolute value inequality to work with problems involving tolerance, where we want a value to be within a range of acceptable values. This is the sort of thinking, the formula we're going to use to work with this. So in our particular example, we're looking at baseballs, and we have this sort of ideal weight for a baseball. We need it to be 5.125 ounces, but we're allowed to have a tolerance. It's allowed to be within a range of plus or minus 1.25 ounces. So our first goal, let's write an absolute value inequality that expresses this range. So start with our actual weight. Let's say we're testing a baseball to see if it's going to work or not. So we don't know what that weight is. So I'll start with x. I'm going to subtract from that my ideal weight, which is the 5.125, the ideal or the average weight. And they may give that to us. They may ask us to find that. That range or that difference needs to be within our tolerance. So that must be less than or equal to the 0.125 we've done as our tolerance. Now notice that even though up here in the problem they use that plus or minus symbol to express it, we're not using that in the absolute value inequality. So there's our inequality that we've written. Let's go ahead and solve it and then figure out what that answer actually means. So do what we've normally done. Let's split this into our two separate inequalities. So one of them is identical to the original, just drop the bars. For your second inequality, keep what's in the bars the same, the x minus 5.125, but then not only do you change the direction of the inequality symbol, also change the sign of your answer, so we're now negative 0.125. If you solve each one of those, we end up with, over here, x is going to be less than or equal to 5.25, and on the other side, we end up with x must be greater than or equal to 5. Now again, since we're dealing with the story problem, we want to make sure we interpret what this means. So each of these are weights, so I'm going to go ahead and throw ounces on there, so those are acceptable weights. And if I think about what I was doing, I was trying to find this range of values. So what my inequalities are telling me is what that acceptable range is. So over here, I realize that my answer means the ball must weigh at a minimum, or at least 5 ounces. It's got to be at least that much, but at the same time I have to make sure I'm less than this. If it weighs more than that, it's too heavy. So I have a baseball that must weigh at least 5 ounces, but at the same time it's got to be at most 5.25 ounces. So sort of a very roundabout, complicated way of doing something we could have done a different way, but there's how absolute value inequalities can be used to express this range, this tolerance.